An alkyne is a hydrocarbon that has a molecular formula CnH2n-2, where N is the number of carbons. Alkynes have a DBE of 2 for every triple bond. So every triple bond is a double bond equivalence of 2. There are different types of alkynes, and the simplest one is acetylene. Acetylene is made up of 2 carbons and it has 2 acidic hydrogens. The reason why these hydrogens are acidic because they are connected both to an sp hybrid carbon. The bond angle of the triple bond is 180 degrees. This is why whenever you draw a triple bond, make sure that it is linear and the carbons that are connected or adjacent to the triple bond, they have to make 180 degrees with the triple bond. When alkynes are now substituted, meaning that they have auto groups instead of hydrogen groups, then alkynes can either have 2 auto groups on both ends of the triple bond, and this is called an internal alkyne, or they can have an auto group on one side and no auto group on the other side. The other side will have still a hydrogen, and this hydrogen still will be connected to an sp hybrid carbon. And we know that an sp hybrid carbon is more electronegative than an sp2 hybrid carbon than an sp3 hybrid carbon. So a hydrogen that is connected to an sp hybrid carbon is going to be more acidic than a hydrogen connected to an sp2 hybrid carbon than a hydrogen connected to an sp3 hybrid carbon. This is more acidic. The reason why? Because the carbons are more electronegative. And another reason is that the sp hybridization is 50% s character, and we know that the s orbital is the closer to the nucleus. So this means that the electrons are pulled more towards the nucleus, which makes this bond a shorter bond compared to a sigma bond between the carbon sp2 hydrogen. This is a long bond, and this is the longest among all the bonds in there. And this hydrogen is not acidic at all. So this hydrogen here, it's the weakest acid. In addition to the carbon-hydrogen bond, we also have the carbon-carbon bond. So if we are comparing the triple bond to the double bond to the single bond, then the triple bond is going to be a shorter bond between the carbons than the double bond, than the single bond. And this also applies to the hydrogens that are connected to these carbons as well. So if the carbon-carbon bond here is a long bond, then this also makes the carbon hydrogen for the sp3 hybridization to make it to be a long bond as well, and the carbon hydrogen for the triple bond to be the shortest bond as well. So if we have a single bond between 2 triple bonds, that is going to be a very short bond compared to a single bond between 2 double bonds, compared to a single bond between 2 alkane groups. That bond here is going to be the longest bond. Alkanes are water insoluble. They are only soluble in organic solvents. They have low boiling point, they have low melting point, and as the number of carbons increase, the boiling point is going to increase and the melting point is going to increase as well. If you're comparing two alkynes that have the same number of carbons, the larger the surface area, the higher is the boiling point, and the lower is the melting point. Or triple bonds are linear, and they cannot exist in a cycle of 3-membered ring, 4-membered ring, or 5-membered ring. Now, if you want to put a triple bond in a cycle of 6-membered rings, that will be completely unstable. This is a benzyne intermediate. It's going to decompose at room temperature very fast. Triple bonds can be included in a cycle of 8 carbons or more because these cycles will have less angle strain now compared to the 6-membered rings or less. But even though the structure will also be unstable. To name alkynes, we need to choose the longest carbon chain that contains the triple bond. And then we need to give the triple bond the lowest number. This is our priority. Our priority is not the substituent, our priority is the triple bond. You give it the lowest number, and then you look at the substituent, and if you can, you give it the lowest number. So here in this example, I can start numbering from either ends of the chain, and both ends will give me the same number for the triple bond, which is number 5. If I start numbering from this end, then in this case, the triple bond is going to be carbon number 5. And if I start numbering from this end, also the triple bond is going to be 5 as well. In this case, and in this case only, you go ahead and you look at the first substituent and you give it the lowest number. So this is why I need to start from this end. Then, of course, you would need to give prefixes if you have substituents that are the same. Give the prefixes di, tri, tetra, etc. And the ending of the parent name needs to end in y and e. So you drop the a and e and you add y, a, and e. So the name over here, it's going to be, this is 5, this is 6, this is 7. So this is a chain of 10 carbons, so it's going to be a decyne. I have to specify exactly where my triple bond is, which is on carbon number 5. So it's 5, it's going to be 5 decyne. I can write it like this, or I can write it as a dec, 5, and an I. It's a preference, and both ways are right. And then I move on to the substituents. Here in this case, I have a dimethyl group on carbons 2 and 3. And I do have a methoxy group on carbon number 7. So my name here is going to be 7-methoxy, 2,3-dimethyl. Remember that the di is not included in alphabetization, so I always need to look at the M in the methyl and M in the methoxy. O comes before the Y. This is why methoxy comes first. And then I would have 5 decyne or dec 5I. If I have more than one triple bond, then I'm going to use the prefixes di, tri, tetra, etc. and start by numbering and giving the first degree of unsaturation the lowest number. Each triple bond will get a number. So I can name this as an octa 1,5-diene, or I can name it as a 1,5-octa-diene. And then you name your substituents. This is an isopropyl group. However, isopropyl is a common name and it's not an IUPAC name. The IUPAC name of the isopropyl is a 1-methyl and it's an ethyl. And those data lie on carbon number 3. Now, if I have a system of a double bond and a triple bond, then I would choose the longest carbon chain, including all my degrees of unsaturation, both the double and the triple, and start by giving the first degree of unsaturation the lowest number. So in this case, my alkene is a terminal, so alkene is going to be my first degree of unsaturation. So that is going to be carbon number 1 because it is at the end. This is 2, this is 3, 4, 5, and 6. Don't forget that a triple bond is 2 carbons in this case. And then because I do have 2 degrees of unsaturation, I have to give a number for each one of them. The ending is always going to be in the triple bond. So the ending is always going to be in the Y and E, no matter what, because alkynes are higher priority in naming than alkenes than alkanes. The triple bond is on carbon number 4, so it's going to be 4-ine. So now here I need to separate the parent name from the ine because I have an ene also. So I would need to put 1 ene. Now the ene, instead of doing it as an E-N-E, because Y is a vowel letter, I would need to cancel the E and drop that. So the ene is going to be just an E-N. So the name is going to be 1-ene dash 4-ine. And of course, the parent name is 6 carbons. So it's going to be a hex in this case. So it's going to be a hex and of course a dash in there. So see how I separated now the hex. The hex cannot be coupled with the Y and E because I have a double bond in there. So you start by the parent name and then give each degree of unsaturation a number. Give your first degree of unsaturation always the lowest number, but no matter what number that is, your ending is always going to be in the ine. So over here, choose your longest carbonate chain. First degree of unsaturation, the lowest number. So here in this case, the triple bond is going to get the lowest number because it is terminal. This is 4, this is 5, and this is 6. But the ending is always going to be in the Y and E. And it is on carbon number 1. On carbon number 4, I do have my En in there. And then the longest carbonate chain, it's a hex. So that is going to be a hex 4-ene 1-ine. Now let's say if the triple bond and the double bond, they are both at the same end in there, and both they are low number, which is carbon number 1. Then in this case, you would need always to give the double bond the lowest number. So if they are both on the same ends of the chain, give the double bond the lowest number, and your ending is always going to be in the Y and E. So it's going to be 1, 2, 3, 4, 5, 6, 7, and 8. I don't care about the substituents and the alphabetical order and the B in the bromine coming before the C in the chloro. I still need to give the double bond in this case the lowest number possible, but my ending is going to be in the ine. So the name here is going to be 6-bromo. For chloro, it's going to be an oct dash. And on carbon number 1, I have my ene, and on carbon number 7, I have my ine. Always choose your longest carbon chain to include both degrees of unsaturation. Give your first degree of unsaturation the lowest number, but because both are terminal in this case, I would always need to start from the double bond. So start numbering from the double bond, and your ending is going to be in the Y and E. This is 7 over here, so this is going to be it's a Y and E on carbon number 6. And it is on carbon number 1. I have my En, and that is a hept. And then I do have 2-bromo. I have my 3-ethyl, and I have my 4,5 dimethyl in there. So let me squeeze those. So this is going to be 4,5 dimethyl. Okay, and the rest of the name. Now, if we have a cycle and we have 2 substituents coming off the cycle, and one of the substituents is the triple bond, then we would need to give it the name ethinyl in this case. And your ending is going to be in the cycle. The reason why your ending is going to be in the cycle, because the cycle is 6 carbons in this case, and your triple bond is just a substituent. So, however, your triple bond is going to get the lowest number due to alphabetical order. So this is going to be 1 ethinyl, and it's going to be 2. Don't use isopropyl. If you're asked about the IUPAC, it's going to be 1 methyl ethyl, and it is a cyclohexane. Alkynes are also named as a common name. So if you want to name alkynes as a common name, you name all groups that are connected to the alkyne on both ends. So here, this is going to be an ethyl. This is a propyl. You arrange those in alphabetical order and put the word acetylene at the end, because after all, acetylene is a carbon and triple bond carbon, and this is the simplest form of alkynes. So this is called acetylene. So the common name of triple bonds is going to be derived from acetylene. So that is going to be an ethyl, propyl, and acetylene. Another example over here. So that is going to be an ethyl. This is going to be a cyclopropyl group. Cyclo comes first because of the C. So this is going to be a cyclopropyl, ethyl, and acetylene. There are additional nomenclature problems in the problem set and in the notes over here, so please practice.